Good morning. Third time's a charm. All right, you going? Let's see. Let's take care of this. Networks. I'm gonna do some stuff with SIMD in the Space Battle Sim. I think I need to work on the output stuff so I can actually use it. This piece of the Space Battle Sim is really a service to the rest of it. I'm looking for. I did look at some SIMD stuff last night. It's pretty impressive, actually. It's really neat. See, I'm trying to get my phone on the little monitor thing. There we go. Got that and that. Now, yes. So here's the general version of the code, like just the regular stuff. I don't know what to call the general version, the common, the non-SIMD one. I just called it base. Maybe I just call it like that. I also decided to not use faster or SIMDs and just use the SIMD intrinsics directly. So we're going to be doing that. Just using the intrinsics themselves. I'm targeting. I think it's a. Should probably put the actual constraint on there. I think what I actually need there is in all x86 targets. I'm not doing the is it the AVX stuff or the AVX 512, AVX 2. Those are a little bit more specialized, and they allow you to do many more instructions all at the same time, because the width is, well, because it's wider. So if we look at the difference here, there were a couple things last night that I played around with that made big performance enhancements. I pass in the shot energy, and so basically this element here is created beforehand, the array that we're going to build the attack into. This is the result value. And I needed that because SIMD stuff works on um, basically widths of data. So if you have something that's, say you have a million elements, well, a million's not divisible by 8. Right? And SIMD stuff will, in my case, if I'm using the U16s, it works on 8 U16s at once, which is pretty cool because it just turns through them that much faster. One of the other things that really sped this up was preload and prefetching. Where is it? Oh, here's a prefetch. So in this case, I'm actually saving into a local array this bit of information. I don't think that's actually as important as the prefetch information that I get out of that. And the prefetch here is really just trying to load the random locations in memory that I'm going to be accessing. And I did that at the very beginning of the loop iteration, so that a couple cycles are actually burned up here during the actual calculation. And then down below, we use those lines here. So hopefully they're on their way, or they've arrived already by the time we need them. See, and we're using fetch here, and you have to give it a hint. Now this hint here describes how the CPU should behave when it receives the data. And in my case, I'm not going to be using the data a lot. So it's going to be in one of these side channel elements. Morning, Nomad. How's it going? Reminded me, people asked for me to announce in the Discord. I'm going to do that. I'm doing well, thank you. Doing well. You know, I should probably describe what's going on here. That, and I think I want to try to get rid of this little targets array because I don't think I need it. I think it's just going to distract things. So we're going to clean this up. I did do a little bit of SIMD stuff last night, trying to get used to it. And again, I moved away from the faster or the SIMDs library. I think I actually learned a bit more about it this way. Here, we'll go through this. So some of these lines are basically copied right out of the documentation. It's only going to build this function if it actually has it. Well, if it has x86, x86, 64, and the architecture imports as well. Nice thing about some of these functions is that they are exactly the same in either x86, 64 or x86. It means that you can use the imports like that. It's nice. Let me get rid of targets. Oh, I see. That was loading into that because I can't. That's right. Yep. Okay. I do need that. Basically, what's going on here is that we want to load up all of the elements that we will save into the targets, the random target info. So here we're just doing 2 instructions in order to fetch 8 elements of data. Should probably describe that. Let's say storing 8 elements into targets using two fetches and 2 saves. And then here we go through and using the 8 element array, prefetch the random memory locations that we will be operating on. Okay, so first, fetching the 8 memory locations just in order to prefetch them. Morning, Carter. How's it going? Actual SIMD stuff today. Load the attack value. Load the energy value. Now load load, was it 8 attack values, load 8 energy values, calculate the power. So SIMD is really neat in that here on my box, at least, I have SSE2, there's SSE 4.3 or whatever. Close some tabs to the right. So on my box, I do not have like the AVX 512 stuff. Just don't. But I do have these elements up here, the blue and the green and the yellow stuff. I also seem to have, I think, some of this stuff. I'm not sure though, but some of the other stuff just isn't actually in the Rust intrinsics. They just don't have it all. Because you have to wrap each one of these elements, and it's very time consuming. So they didn't do everything. It's like that when I hover it opens up. Oh, and other you can see here. Actually, why? Oh, because I have a filter here. I was looking for a way to get remainders from numbers. And it looks like the SVML stuff has it. So you could do some division and get the remainder. However, because this would be very useful for generating random numbers very quickly, I would like that. Rust doesn't actually expose this. So I'd either have to do it in assembly or something else. Don't really want to go to that level. Okay. Calculate the max power. Reduce it. Well, I guess, each, I think I'll understand. And then down here, we're actually storing them back out to our arrays. I did get my first seg fault in Rust because I did something naughty in a unsafe block. That was exciting. Makes me feel like I'm doing C again. And because you can only do, in my case, 8 elements at a time, because I only have 128-bit kind of instruction width, anything that's left over, I have the kind of generic version of this function do the remainder. So this build attacks is supposed to produce the same output as the build attack SIMD, so I can actually compare them against each other. Which I think would be a really neat test to have for build attack SIMD stuff to make sure that it's producing the same output as build attack. Actually, we could do that real quick. Test build attack. This will just be for verifying that the SIMD is the same as the other one. We will need 2 pieces of data. Well, 4 pieces of data. So we need the ship attack, the ship energy. So a couple of vectors there. Random targets, okay. So let's create something like 10 or let's say 15, something that's not divisible by 8. So we know that SIMD stuff in this case is only going to do 8 at a time. So I want to make sure that it falls back to the generic version as well. We're going to say let attacks equals, it's going to be just some vector. Let's say we have 14 of these. We could create 14 of those, or we can do that extend width or resize. Let's use resize. So I think I want 2 different types on there. Next on resize, we want it to resize to, let's say, 10. The first type of ship and ship attack. I am starting to want to get rid of those wrapped elements there. Let's say it attacks with power of 10. By default, if it has the energy to attack, do that. That should resize that. Oh, that's right, I did get rid of that. It's just 10 now. Then we're going to have 2 other ships. That was 10 ships. Let's do 4 ships. I'm going to resize to 14, filling in the blank with some bigger ships I can attack with like power of 30. There we go. Now we need energies. It'll be very similar. This is their reserve tank in their weapon system. So we'll say that they have energy of 50 in this case. Maybe they can do 5 shots, and in this case they have like 300. And now for the random targets. So who's attacking? We're going to just write these out freehand. See, this one wants to be a U32. So in this case, the first element's going to attack the 5th underscore U32. Now that the type is in there, we don't have to describe each of the types. Let's say 2, 6, 13. It's the last one in the array, okay. 11, 5, 7, 9, no. 2 again. How many are we? Do we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, and 5 again. Okay, that's our random sampling. I think we have 14 elements in there. 1, 2, 3, 4, 5, 6. Reminds me of a Godot newest stream. The counting. I love his stream, and I love his demeanor. All right, so we have random targets. Now we need something to hold the shot energy. Basically, this is after the calculation, before it gets applied, how much is going to be actually applied to the target ship. In this case, let shot energy is going to be equal to a vector 0, which is a U16, and we want 14 of those. Okay. Now, I think what I actually want to do is clone these because I want to run them against each other and then compare the shot energy. So in the end, if we write the end of this function out first, we'll have, say, build tac, and it's going to have tax energies from something like that, or we'll have to pass those in and then SIMD version. Okay. And then after that, we will compare these two shot energy elements because that's basically the output in this case. Shot energy 1 versus shot energy 2, and that'll tell us whether or not they are doing the exact same thing. Let's rename these to 1, and then we'll give those a clone afterwards. There we go. 2. That should be a 1. Oh, it's early. Oh, we had some lightning last night. Thunder and lightning. There we go. Then we'll do 2. And find shot energy 2, and the reference types are actually wrong. In this case, so just borrowed. These are mutably borrowed. Random targets, just borrowed. Shot energy is mutably borrowed. The energies are mutably borrowed because as somebody shoots, their energy goes down. And the shot energy, this is the target that we're collecting the energy for. That will be applied to the target. Oh, and now we need to clone all of these before we actually operate on them. Let it tax 2 equal. Let's see. This one is shot energy, shot. Did I spell that wrong? Oh, I forgot the G. Great. Now we can actually see if these things are doing the same thing. Oh, cargo test. There we go. Index out of bound. Index is 5. Panic hat index out of bound. The length is 2, but the index is 5. Oh, yes, this is incorrect. That should be a semicolon. Now it has 14 elements. There we go. Oh, great. Now we have a little test actually verifying that the SIMD stuff does the same thing as the regular attack stuff, which I was hoping for. I wasn't actually certain. Okay, but if we go back to the SIMD stuff, there's more that needs to happen. So one other thing that has to happen here is that a ship during a round gets to fire until its energy is done, until they're done firing. Now, how do you do that? Well, it's likely that all of these 8 ships that we're operating on at the same time are going to still have energy left over. So I'm willing to take the risk and say, oh, we should just do this until all of those elements have been all of the energies of those 8 ships have been expended. I'm going to need some way to know, are all of them empty? And I think there is a way. If we go back over to the SIMD stuff, first I tend to look at the Intel intrinsic stuff and then go to look in the Rust documentation to see if it's actually supported. Well, sometimes it's not. But we want to see, is it logical? I want to see how many bits are available. There's a bit count. Okay, let's filter this based on technology. I think I'm just doing the SSE stuff. Blend. Oh, they have ceiling. Let's blend do. Compare. Things are compare greater than or greater than is stored in the destination. Oh, they have CRC stuff. Oh, that's neat. I guess that's why some CRC stuff is so fast. What's CVT? Convert? Oh, I see a CVT. Single precision 32-bit floating point elements store the result in the 2 lower elements of destination. Fine. I don't need to convert. I just want to see how many bits are available. Extract. Extract a 16-bit integer from A, selected with. That's neat. So they have different floors. Here we have ads and stuff like that. Okay, I want a count. You can search for things in here, but you have to know the right terms for it. So what is this? This is, hey Max, how's it going? At the moment, let's see, we added some testing. We have some tests to make sure that the output from the SIMD battle stuff is actually the same as the normal version. And at the moment, I'm trying to implement the ability to what was it? Oh, to keep firing it around. So ships keep firing until they're out of energy, not fuel, energy. I'm trying to find the instruction for counting the number of bits that are still on. All right, SIMD count bits, not butts, bits. Where's the water? See, I thought they actually had an instruction for this. So it looks like it might be, is this a op count? WCNT? Take all of those off. Count bits. Oh, look, it's in orange. What is KNC? Oh, here we go. This one's in gray. Count the number of bits. Set to 1. In unsigned integer A, and return that count. Let's see, does this have to be aligned? Yes, AMD supports them as well. Intel just has a really nice guide for doing this. But most of the instructions I'm using are just in this block here, so MMX and SSE stuff. I think that also works on AMD stuff. But it'd be possible to detect at runtime what the chip actually supports and call the appropriate function. So on like a production server, you could ensure that you're actually going to be using a machine that has the fast instructions. But if you're just doing local development stuff or testing, you don't have to have I guess a CPU with that instruction set. Well, the pop count stuff, that's kind of interesting here. Okay, because I have to actually call that 2 times. Because that'll count the instruction, there basically the integers in 4 U16s for the energies. Basically, I want an inner loop here that keeps um, firing until the energies are gone. So after we have stored or here, I want to count the 8 bits. That's 128 bits, isn't it? So I'll have to count it in energy over here, so I won't have that otherwise. Oh, does it even have that? Okay, we have to check the Rust docs first. Nope, they don't have pop count. Okay. That's a bummer. So at the end, we check to see is there any energy left in any of these, and keep going. I'm just checking to see if that, yes, these two things can be moved down here. This is the advancing of the pointer that I'm using. And we do not want to do that if our energy is not 0. So we're going to loop around this unsafe block. Or let's see. While has energy. Ooh. So in this case, we can use, we need to sum up those 8 elements. Energy 0 to 8, those first 8 elements. Iterate and sum those. Yeah. So if 0 is equal to the sum of those 4 things, what does it say? The trait bound sum is not satisfied. Because it's borrowed. It'd be great if you could just call sum on that. Oh, is it? Is it upset because it wants to do U16s or U32s? Interesting. I wonder if I can re. See, I just want to add all 16 of these elements together. I think there's an instruction for that. That would be nice. Let's see, we want, back over here. See, do I have the browser warning up? I don't, and it's on a white background. I don't know how to choose the color on that. I'll leave that off. All right. So we need arithmetic and probably just these. Compute the absolute difference. It's an add side thing like this. Oh, this is saturated. Is this horizontal add? Let's see, what is this? Horizontally add adjacent pairs of 16-bit integers. Cool. That will work for us. Now these are, it's treating as integers. We want each add. We want the unsigned integers. Using saturation. Okay, that's good. So we don't want to wrap. That's saturating. Back. Okay. Horizontally add adjacent pairs of signed 16-bit integers. Signed 16-bit integers. And this one doesn't do a saturating add. But these two down here do. I mean, really, if I'm just going to be using this as a boolean, I don't really care what it's adding as long as the bits are on or off. But if they're signed, then there's the risk that, well, that you'll add like a negative number to a positive number, and then it'll be 0 as a false. I'm surprised they don't have an unsigned version of this. I really would have expected that. Let's just go with the saturating add one. Oh, good, they have each add stuff. They have MIPS, they got all sorts of stuff. Goody. Use this one. It takes 2, but it says adjacent pairs of. Oh, that's not what I want. Actually, I think I chose the wrong thing. So this horizontally add. So in this case, destination A plus A, even though it's taking 2 elements here, it's taking A and B. So it looks like it does all of A and it does all of B, but I don't have anything for B. I guess I could just set set B to 0. Seems wasteful. I doubt you can even pass 0 to that. Yep. I think there's a set function. Let's double check on that. Come back over here. Set. There we go. It says 0 SI 128. Perfect. So we can sum those up and then set those into some external value. We need store like a 64-bit int or something. You know, let's come back over here. Here we can actually choose store. Stream store, store U, that's unaligned. Interesting. Then they have stream, non-temporal hint. So we're going to use the store L. I think it's L. I'm hoping that when this does its add, and we give E as the first value here, that ends up going into the lower portion of this. And we can store that value here. It says that stores a lower 64-bit integer into a memory location. Okay, well, what is our memory location? Energy sum is going to be a U64. Can I give it that energy, that location? Oh, wait, I can probably give it mutable reference to that. Followed by some. Hmm. I wonder how you do that. Because I know we can do this with an array, but I didn't want to have a single element array for this. Seems silly. Yeah, and that's just wrong. Because here it's going to take this as a pointer to somewhere in memory. Just obliterate something. I want to say a seg fault, I think this will cause it. I have a vector of one element. Expected type. Oh, equals. Okay, there I think it's saving it into that array. So we're getting a slice. So do I need this outer bit here? I think I do. Hmm. Oh, that's right, because you can say as pointer and then do a dot offset if you need to. Should be the root of it. Okay. Well, since that's already been added up, now we can say if the first element in that energies thing has power, energy sum. So if it's not equal to 0, then it has energy, and we'll do this again. All right. Now this should cause the test to fail. Be good to see. Now what are we looking at here? This is the amount of energy that's going to be applied to the targets. I think in this we should also check that the shot energy is empty. Energy is 1. Some of that should add up to 0. And this is going to be assert that energy is 1. 0 is going to be equal to energy is 1 dot iter sum. There we go. The same thing for the second one. I think that's going to fail first. Because, well, the first one, yep. It's our build attack we didn't modify. Consume energy for the attack, and do this, and here. This one's a little different. Okay, I was going to do it the same way, but I don't need to. I think I can just say while energy while energy is greater than 0. Great. Wow, that's really encouraging. That's really encouraging. Now, the downside is that at this very moment, it's attacking the same ship with all of those shots, which means that one ship is just going to get hammered on by the same thing. I don't think that's what we want. We want a different ship to actually get ahead. Now, how do I do that with the random targets? The random targets is already set. Need to choose a different ship each time. I could call the random generator given a certain seed. Because in this case down here, I need to produce 8 random numbers. The one up above, I have to produce 1. And they should be predictable based on the inputs. Hmm. I do not really want to overwrite the random targets. I'd like to not do that. I'd like that to stay consistent. What if I should just integrate this randomness back into the other system and not initialize it from entropy, but from some other value? That way the sequence of random numbers is consistent between tests. What if you remove the ones that don't have energy and then loop back through? Oh, interesting. So basically clone the array. Oh, that's interesting. So basically keep building the attack, stripping out the attackers as they run out of energy. That's interesting. Well, in one case, so in build attack here, in the normal Rust code case, we end up operating on one attacker at a time. So we don't need to do that in this case. And in the opposite, in the SIMD approach, we're actually doing the same exact thing with about the same number of instructions, just operating on 8 at a time. And there's no penalty to there's no penalty to, how do you say that? Kind of running the empty ones through. Right? If they're already empty and they're next to somebody that is going to shoot, then it's okay, because of those 8, there's probably at least one, hopefully more than one, that needs to be calculated at the same time. I don't think emptying them is going to give us that much of a gain, because in the simple case, we're operating on one at a time. We don't have to filter them out. And in this case, we're operating on 8, but as long as one of them has something to do, I think it's a gain. Because in most cases, we're going to have more than one operating at the same time because we'll have basically fleets of ships. And only where you go from like the fleet boundaries, you go from like capital ships to fighters, you might end up with a capital ship that's wasting a bunch of fighter time. I think in the majority case, it's not going to be a waste. Oh, do its thing. Just wanted to see what that does. Run this through twice. All right, needed shield fuel, ship fuel. Oh, this is actually a lot higher than it had been. It's good. Run it one more time, just this computer has to warm up. Once this thing gets nice and warm, it's 3.3, whatever will go down to about 2.8 spawn stuff. And if I'm not doing as much, like encoding video and all this other stuff, but usually it's faster than that. Yeah, that adds 10 seconds to the attack duration. And if we go back and do this with just straightforward Rust version for building the attacks, so this is going to be kind of an example of SIMD versus not SIMD. And right there, that took 35 seconds total with the battle calculations. Where was it? Attack duration of 25. 25, 35. It's got many more iterations to do now. Who knows, it might be faster. Whoa, 22. All right, Rust, you win. Give up. Let this be a lesson. That's awesome. Actually, that's really, really cool. My SIMD code is slower than the Rust code. Way to go, Rust. Way to go. That was my first attempt ever writing SIMD stuff, so. What was it then? I know that before I ended up getting a speed gain when I ended up doing that. it's saved, right? Just want to make sure. Well, that was fun though. Yeah, 22. Oh my goodness. All right, Rust. Stop showing off now. I think that's a good enough reason for me to scrap the SIMD code. That's amazing. My SIMD code is running slower than the non-SIMD code. I think as soon as I added this outer loop here, this block here ended up winning. I mean, maybe it's not equal. But I think the test showed that it was equal. Yeah. All right. Here, get status. Get add source. Cargo. Before I delete it, I'll get it committed. I'm surprised. I am surprised. And then I tell myself, you shouldn't be surprised because you're an absolute novice at writing SIMD code. So maybe there's something in here that shouldn't be. I mean, just the, maybe this stuff up here, putting the targets. No, that's in the loop. We probably want that. All right. It was fun, SIMD. It was fun. I know when I'm bested by the compiler writers. Build attack. Let's clean up tests. I'm guessing that it ended up hitting some sort of op path or some sort of optimization in LLVM. Oh, that's right. We also got a new update. Rust 1.43 is out. Awesome. Oh, yeah, I don't want this one anymore. How do you remove those? Stop. Toolchain. Uninstall that. No toolchain installed for that. Target. No. There we go. Much better. Oh yeah, and I was playing around inside of this. I can close that. There we go. Okay. So from there, I thought that was educational. That does mean that attacking other ships becomes easier. So while we have this random set of ships here, we should be able to move that in now. And use some sort of predetermined iterator there. Let's see, does this attack distribution have an iterator that you can pass in? Because if I just want to create an iteration, basically an iterator from this, I think that'd be nice, because then I could have either the random number generator actually power it, or I could have something else that provides the same sort of interface generate it. Let's check on that. That would make it really nice for tests. It's not there. Structs. Actually, I want to see what the traits are. RNG. Sample iter. It's a dist iter. Nice, so it looks like we can adjust this to just provide the iterator for that. Let's do that. We'll have to bubble these things up. Taking that out of there. How's this? Toss that at the top. Now we have a RNG from entropy. That's fine. X distribution. Now in this case, it was going to be the maximum of either one of the armies, but we don't need that anymore. Now it has to be more specific. So before we attack, we need to know that army's attack length. RNG, you can be up there. Clean that up in a bit. So this build attack, we want to not pass in random targets anymore. So that's going away. Oh, did the install finish? Haha. I might actually get a perf gain from this too. Made minor performance enhancements. Okay, we'll take the random targets out and give it the random iterator. So I'm kind of waiting for this build to finish. Clean up some of that. No longer going to use random target like that. It's okay. 3 arguments, 4 were supplied. Yes. I don't know what the type of the random iterator is. I think it's this dist iterator thing, but it implements an iterator. So we'll call it R. We'll say, we'll take one of these things where R is iterator of numbers, U32s. Okay, make that generic. Type mismatch. Expected U32, found U size. Ah. Perfect. Okay. So we got that. Oh my goodness. 6 months ago, I could never have done that in such a short amount of time. That should give us our next element. I have a feeling that it gave me an option. Yes, it did. Next. Why would next ever fail on that? Oh no 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 no! I'm not an expert on Rust in any way. I think a number of people. I mean, Musean might be in here. Musean is more of an expert than I am. And then there are, I mean, Alex Crichton. Um, well, I'm trying to remember their actual names and not like their GitHub names. Um, and I am blanking on all their names right now. Carl. Um, Probably also burnt. What was it? Burnt sushi. Hmm. We don't need offense. Maybe I should be using that. Here, offense length, defense length. Like calculating that over and over again. Oh, and I probably need to set up this again for the defense. I don't want to use the same one because we need the length, the uniform distribution to be different. Trying to keep the order the same as up above. Here we go, and defense length here. All right. So now it should randomly choose some other ship. Oh, let's see, that's refuel. I don't want refuel. This is the battle loop. Super simple now. Tag is limited by how much energy you have. So whatever is less, your total, like your ship's specified attack power, or the amount of energy that you can actually spend. Reduce the energy that we have. Let's see, we're summing this up. We're like pooling this. What's another word for that? Collect. There we go. Okay, that's gonna do its thing. See, this is in spawn, isn't it? All right, let's give it a go. Oh, build random. Yeah, 69 nanoseconds. That's great. So that was it 1 second that used to be in there is now going to be much longer because each of these ships is attacking more than once. So we might have like 3 or 4 seconds of actually random number generation for this. But I think this actually makes the battle round quote unquote to spec, because now things are going to be getting their second or third attacks in. And in my case, I actually think they're getting like 10 attacks in. So there's a lot of energy on these ship specs. I wonder. They should shorten the rounds needed. Yes. Yeah, because there's going to be more damage done, right? So in this case, it took a minute and a half because, well, they just dumped all their power. Let me look at that. Shields. Yeah. How many ships died? Oh, I just destroy ships. All right. So I think next is going to be kind of outputting stats. And we're going to need some sort of data coming back out from this. Total fuel given remainder. And maybe some more tests. I think I'd also like to get rid of some of these, convert these into actual types. Hmm. Because that took a minute and a half for that round, and that's 200 mil on 200 mil. I'm surprised that the refuel still only took like 4 seconds. Refuel was taking a while before too. I guess it's the same number of ships, so that shouldn't have changed. Only the battle time should have changed. $1 million versus 200 million take. It's going to be, I'm guessing, half as long because this is for a single round, and in that case, we're just removing almost half the calculations. So in this case, if we went with, instead of defense, 1, 2, 3, 4, 5, 6. There we go. Run it again. Gonna have allocate less memory, a lot less memory. Yeah, this is allocating some 5 gigs on my box. Oh, bombed out. There we go. 328. Target ship index. Attack energy. The targets. Interesting. I have a couple value swaps somewhere. I'll just toss it on air so we see it. I missed a quote. It's not. There we go. Actually, let's drop the size of this down. 200 million. Ooh, I think I barely caught it in time. Attack energy count is... Yeah, we have many, many more attack energies than we have targets. I swapped some of that. Let's see. Attack energy is supposed to be set there. And we have defense. Their attack energy here. Defense length. Is attack energy getting ended to? Oh, I attack the defense. No, to the offense. Attack energy. We're building the attack. Okay, this is our attack. Who we're attacking is configured by the uniform distribution of this random number generator. As long as we have the defense length correct, that's fine. Oh, no, this is not okay. Okay, I have to get rid of these. Offense length and defense length. Oh, those are the same, aren't they? But they're backwards. This should be these are the targets. So we shouldn't be targeting up to like 200 million or whatever. It should be 100 million because it's the size of the defense that we're actually using there. These technically are backwards. Should be up here. This one down here. Because now we have our attack energy for the size of the offense, and then we have our distribution for the size of the offense, even though the defense is attacking the offense. Okay. There we go. That should do it. Much better. Okay, 1 million against 200 million. Oh, I forgot to remove those errors. Yeah, 13 seconds. We had something a little bit more reasonable. Maybe just 20 million on 1 million, 1.5 seconds. A couple things that are still bugging me. Like these vectors here, ship defense, fuel, and support. These are pretty much single value elements, but they are wrapped up, except for ship defense, they're wrapped up in another type. Tempted to split the shield and hull into two different arrays. Same with the, and then just replace the ship fuel and the ship support with actual values to simulate, or actually to be more in line of what we have here for attack and energy. Actually, the only reason I split those up was for the SIMD stuff. I could go the other way and put those back together and get that type info again. Ooh, that might be better. Actually, I'd prefer to have the type information so I get compiler errors where I want them. So I know that this U16 can't be put into the other U16. So maybe going back is a better answer here. Okay, let's get rid of ship attack and ship energy. Basically, where to go? These two elements can be kind of like the ship offense as opposed to the ship defense. So here we have ship defense, and we could have hub offense as a vector of ship offense, which is these two values kind of bundled together. And then we get actual type information and avoid a couple more bugs. So we need to have a couple more derives on that. Offense, defense, that's good. A couple minutes. Starting at the top of this, I'm going to set a marker there. We'll go into spawn ships. Our armada. Now have offense. Oh, that's right. There we go. Now we can get rid of energy. Destroy. Or forget about it. Okay, there's spawn ships updated. Build attack. This will have to be mutable now. Same here. Ooh, tax. We'll call it a tax. All right, so for every ship that's attacking, Ship is going to be offense. So while the ship's energy is greater than 0, and destroy we already did, then there's just refuel. For every ship in the Armada. Here's our energy. So yeah, it looks like at this point, defense is okay there. We're looking for the energy of a ship. There we go, so we can change it. Ship energy here. Where is this? No, we can't do that way. Look at immutable reference to the ship. And then here, it's energy. And here we can put it back. There we go. Build attack. Oh, and the test. Yes, yes, yes. And the same thing for that, for the attack. Type annotations needed. It needs to know what to collect it into. Revit, good morning. Revit? Revit? Is it an E or an E? It's going all right. Sadly, I've gotten rid of the SIMD stuff as the compiler is generating faster code. So good for Rust. I did have fun working on the SIMD stuff. That was a neat sort of adventure to get into. Now in this case here, we're just kind of morphing some types right now. Yo Vibes, what's up? How's it going? Yeah, collect just needs to know what type to put this into. Vector of U16s. There we go. Ah, pretty good actually. Pretty good. So I'm gonna run the sim. We have 200 million or 20 million ships attacking 1 million ships. Here's what we're at right now. How many zeros are in here? 1, 2, 3, 4, 5, 6, 7. Yeah, so 20 million on 1 million. 17 seconds. Not too bad. I want to go see what it was last time. I forgot. 1 second? Really? Oh, you never used Godot or Rust. Oh, man. Actually, I'm trying to compare these two sim runs. In one case, a lot of fuel needed. In the other case, I think all the ships were destroyed. Distribution percent, not a number. Yeah, because you have no ships available. Actually, that down a bit, didn't it? Unreal Engine 4 is a pain. Oh, you want to be a 3D modeler. What do you do your modeling in? Blender, Max? Blender? Yeah, I like Blender. So I added that. I want to just take a look. So this there, that took, oh goodness, hardly any time at all. Oh, because it was counting the CPU time before, or compiling it all. That's right. All right, and where are those errors? Oh, this one. I wanted to get rid of that. I was debugging. Pretty easy to rig stuff. That's cool. Yeah, what was that? The 2.82 update? That stuff is nice. Yeah, that's UI overhaul. Yeah, I actually bought a course on Udemy for Blender stuff. I need to actually spend some more time in it though. That was pretty good. Is this 1, 2, 3, 4, 5, 6, 7? So 10 million ships on 20 million? That's right, I removed the log line. Okay, the other thing that needs to be fixed is in main, hard-coded some stuff and made args. Not required here. Let's fix that. There we go. That's better. Oh, I like Lua. Programming a text-based game. Oh, that's cool. In Python. Hmm. The 3 seconds, that's not bad. Oh man, I've done a lot with Lua in the past. Lua's cool. I embedded Lua in Erlang. I made like a node Lua system, so you can have like a Node.js, but with Lua and Erlang. It never really took off. It was fun. It was really fun to build. Yeah, they just don't have the libraries. They just don't have the term support for that stuff. And what do you mean you can't use sound or colored text? Is that in? I know people use sound with Lua. Well, it's usually built into something else, right? Lua's moving other pieces into some engine that it's in. But I thought they had sound stuff. Python does have a lot of libraries. Okay, so the next piece of this is stats. You need to be able to say, what was the result of this round? I think I want to do these like per round. Like you say, go, does it? So maybe run battle should be run round. Run battle round. Like WoW add-ons, yeah. And Python. Python is a neat language. And it's very, very popular. Lots of people are doing a lot of things with Python. This is going to take a config. Battle config with an anyhow result. Yeah, I think my favorite still is Rust, though. Been practicing it for a while. Trying to get good at it. Well, trying to get less awful. Yeah, Rust has amazing documentation, which is absolutely needed for something like Rust. They spent a lot of time and effort on documentation, and I really, really appreciate it. And I've liked their community too. Like getting into the Discord channel or like the Tokyo Discord channel, they're very, very helpful. I mean, if it's kind of a safe for work or PG-13 sort of thing, you could drop the link to the game in there too. Let's see. So let's see. We have a battle round. I want to do multiple rounds. So the battle config's going to have multiple rounds in it. Sorry, I got a little lost here. Where is that? Where is the battle config? Oh, it's in Sim. Got it. Okay. Rounds 2, or let's say 3. 3 rounds. And that needs to be an equal sign. Equal sign. There it is. Main args. Oh, Sim. Size is not an iterator. Oh, that's right. 0 dot dot. Unused. Fine. That's probably don't need that unless I'm logging stuff out. Round. Right, so we're going to need some sort of output for the battle round, which describes everything that happened in detail. Lots and lots of info. Because that's what this game is all about. Lots of information. Trail. Suspense. Destruction. And love. One of my favorite games ever is Hold on, I have to. Lovers in a Dangerous Space-Time. I didn't want to get the name wrong. But it is. It is an amazing game. Love, love, love. Smash ship. Yes, okay. Yes, well, yes. Now for some stats. But that game there is lovely. It's a cooperative play game. It is just, I just adore that game. So what I'm going to do here, run battle round. Battle round's going to do stuff, collect stats, and it should probably return some sort of round stats. Woo, love. Yes. Princess Bride. We'll probably have some sort of struct. You're just going to dump this here for now. Stats round. Offense. Armada stats. Then we'll have some sort of defense. Armada stats. And that'll include like all sorts of stuff. How much energy per round was used. How much was refueled. Right. Should create a stats thing. Source stats. Save that. Come back. Put that in there. Armada stats. All right, so what are we going to need in here? This is going to be, say, shots fired. Some fun stuff too. Ships destroyed. 32. Ooh. Say ships. Because destroyed could mean your own ships were destroyed, and it could also mean that the others were destroyed. You need to differentiate that between, oh, I killed this many ships, or I had this many killed. Hmm. Should render the battle in ASCII art. Yes. And no. And I don't know, maybe. There's some neat libraries out there for that. I mean, you jest, but what is it? There's a library, which is, come on, brain. There's a roguelike. What do they call it? It's say Rust. They changed their name recently. I'll have to look this up later. My daughter actually uses, oh, the RLTK stuff. That's it. Because it's now called bracket lib. That's it. All right, let's go back. The bracket. All right, so bracket lib, I think, depends on this bracket terminal thing. And bracket terminal provides, ASCII stuff. You can render the curses with this, which is just amazing. It means that you can render all sorts of stuff to that. I forget what library they're using for that. Say dependencies. They got some neat stuff in there. I know that they can take certain kinds of images and render them out to terminals. This is a really, really neat setup. So text sprite. Oh, that's right. And they also have this. Oh, from RexPaint. Yes, try it with WASM. This is cool. But loaded this, and this is like a simulated. I guess they're using WebGL here. So this is their WebGL target, and load to the terminal like this. This is just amazing. That's awesome. I really like this interface. I think this sort of interface should be the game interface. That would be awesome. They also have walking around. They had um, better examples. I think that's on the other one. Try with WASM. We'll try this one. Yeah, here they have a map generated, and you can basically render all sorts of stuff out. Kind of have the dwarf go to different layers, see what he can see. Take him to the top of the mountain. Or maybe that is the top. Go down into the valleys. He doesn't like going like off cliffs and stuff, so be a little careful with him. Yeah, this is WebGL and Rust. Trying to climb up the mountain. There we go. Oh, we can see that there's like bottom to this. I climbed the peak there. Anyhow, that's fun. Yes, that is very Dwarf Fortress like. And there are some amazing little libraries out there for building that. That's that. This library here actually does most of this for you. But I think they also have like text, so you can have little dialogues and stuff show up in there, and all sorts of stuff. Like it's just amazing. A lot of fun. MIT licensed, yay! Okay, back to code. That was a fun little aside. Destroying ships. Okay, opponent. Ships destroyed. And then just ships destroyed, I think. No, because that'll be on the other side. Yeah. Ships destroyed. Let's see. Weapons energy used. So why don't we just make these all U size so we don't run out of space for that. Those numbers can get actually very large. Say shield. I don't know what to call those. Basically, how much energy did you put out? How much energy did you absorb? Full damage. Shots fired. What else? Because we don't have a hit or miss system, so there's no like shots hit, shots missed. If you fire, you hit. I don't know, is there anything else in there? Because as we go through, a ship will randomly fire at another ship. I guess like after this, it's kind of like which of your classes are still surviving. So we'll have total ships. So this will be ship counts, ships remaining, and this will be a vector of kind and type. Ooh, kind and count. That's what it was. Would we want this broken down by kind? Like by ship kind? Because we wouldn't know how many ships they destroyed because it could have been a cumulative effort. Oh well, your expensive ships did. So some of this. So how many of this kind were destroyed? How much energy of this kind was used? Shields, hull damage, shots fired. think the one thing that I miss out of this is like how many ships did they actually kill? And that's not something that we can track because a ship being destroyed might have been destroyed by more than one attacker. So right now, what happens is a ship attacks, the energy goes into a pool, the pool gets applied to a destination. Jeremy, morning. Agmister 4000, how are you? We got a chatty crew this morning. Happy Friday, everyone. Happy Friday. So for this kind of ship, how many do we have left? Remaining. Destroyed. Energy used. Shield used. I wonder if there is a way to say what sorts of things you actually hit. We could say how much energy you applied to certain kinds of ships. Chillax time, you must be in Europe or overseas somewhere. I don't get whiskey till this afternoon. At work we have a whiskey club, so Friday afternoon, get out the whiskey. Even over remote too. So everybody in the company is like remote right now. So this is also interesting. Oh, you start streaming when you finish work some days. That's cool. Yeah, I try to keep it consistent, but you never know. Like some days you just have to binge watch Netflix. So when an attack is done, when we actually attack something, let's go to the attack code. When we build the attack, we basically know what the target ship index is, and we could look up the target ship kind. We could say how much energy was applied to that kind of ship, and how many shots were applied to that kind of ship. We could include all of that information. Whether or not it actually kills the ship, we can say we attacked that kind of ship. Series don't watch themselves? That's right. Oh, what's your favorite series on there? Let's see. Well, it seems like some of the destroyed, that's going to be different, but energy used. And these things seem like they're against a kind of ship. Construct. Target stats. This also will have a kind, U8. We'll have a vector of these. Oh, is that the reboot? Picard? That's cool. One of my favorites on Netflix is Nailed it. The host is great. She's a good actor, I think. Seen her in a couple of other things. Oh, she was in oh, what was it? The Good Place. That's right, The Good Place. So the target stats, how much energy went into this target? Energy shots. We can move those out of there because that's just a sum of those other elements. And then we could have target stats. This would be a vector of target stats. What else would we know from the sim? So yeah, for that thing, we know how much energy and that an attack was made. You can kind of calculate that out. Ash versus Evil Dead. I I concur, actually. Yeah, that's I like that show, especially. I mean, it's good to see Ash actually getting work. What's his book? Memoirs of a Chin or something? So we'll know the attacker kind and the target kind here. So we'll have to be able to track that. That'll be good. What am I missing here before I start to jump into this and do these? Is now an essential employee. Midnight Diner is good. I haven't seen that. The barkeep looks like a Japanese version of your father. Oh, that's funny. Someday I will reveal a video of my father. Um, he 10 years ago, maybe 11 years ago now. I was visiting his place and I told him that I could put things on YouTube. And they go, yeah. And I take my camera out and I start recording this video. And I record this video of him just making all of these silly faces. And then at the end he says, put that on the internet. And so it's on YouTube. Um, it's private, but it's on YouTube. And I showed it to him. Yeah, I can't wait because he's probably forgotten by now. It's gonna be great because I like that's gonna be one of those moments where I pull that out and like, this is my father. Ah, older people and technology. Lovely. Okay, so what am I missing? We'll be able to have the offense and the defense. They'll have these Armada stats. These in order. The Armada stats will have stats per ship kind. Are still out of order. And the ship kinds will then know how many ships they destroyed, how many ships they have remaining. I guess remaining and destroyed, that's kind of like the same thing, isn't it? Because, I mean, how many ships you destroyed, that's on the other side. We'll just keep remaining. because the number of ships you destroyed are actually on the other ship's stat, the other fleet's stats. Shields used. So how much energy are shields absorbed? How much got past your shields and damaged your hull for this kind of ship? And then this kind of ship will be able to know. We don't need the kind in there. Oh, target kind. This is the target. So of this other type of ship, of that class, how much energy did I pour into that and how many shots fired that way? Anything else? Because this will be per round. And we could have other things like the max energy one ship absorbed. That'd be interesting. I think there's like fun stats like oh, refueling stats. We don't have refueling stats in here. Because after a ship has gone through the round, if it's remaining, then it gets refueled. Do we do that by ship kind? Or just in general? Seems like, because we'll know uh, the amount that you can refuel over here. Basically refueling defense, how much fuel was available at the end of the round, right? How much fuel is needed to actually um, fuel up that ship's tank. This is always 0 currently because we're not tapping into the reserve fuel. I think as the rounds go on and the supply fuel is diminished, then ships will start to tap into their own fuel supply. So we have this sort of information already. And this is in total. This isn't by ship, but it could be broken down by ship. As I think distribution percent, fuel given. Were we able to refuel like 100% of everything that we needed? Let's do this per ship kind. Eh, there. We'll have the kind. And then per kind, how much we needed for fuel needed. But I need to stand up. I'm going to raise my desk. So I'll take a moment. 62 cranks. Or 63. I always lose track. But I've got a chair that has a little, like a hydraulic thing in it, and the hydraulic thing is like going bad. But occasionally, just lowers me. I can't stand that. I would rather have like that old school, just spin the thing. Okay, we're almost there. Now stand at the desk. Just not at the right height. There we go. Okay. Fuel needed. Yes, it's all going to be needed. So fuel, shield. Is this kind of the same thing as shield full damage over here? Or energy shots? And maybe not. Maybe not. Here, we'll include it all anyways. Um, Now this is per ship kind. So we want total fuel available. So what does refuel percent mean? Refuel percent is how much of a demand there is, like, or rather, can we meet the demand? So one means we can refuel everything. Distribution percent though? Total fuel given. You'll need. I don't remember what this one is. Anyhow, the amount remaining due to floating point error. I keep track of the floating point error. So then I go through the supply ships and deduct that. That's going to be a F-32. Should probably just make it an integer, hide some information. Go, well, it's at 50, it's at 3. I wonder what this distribution percent is. I wonder if I have a bug. Total fuel given divided by the fuel available. Oh, I see. How much of our total fuel supply did we use? That makes sense. Total fuel given should be available here. Just by summing that up. Oh, no, by summing all of this up. I'm guessing refuel percent is also a portion of that. We should be able to see the demand and whatnot. I'm trying to just limit the number of things that can be calculated later. I keep the little pieces added up. Oh, and this isn't by kind. Oh, this could be supply fuel remaining. Nice. I do think it'd be neat to have like max energy absorbed by one ship, like the hotspot award, stuff like that. What other sort of silly ones can we actually build into this? Kind of like the perfectly tuned, like lost all your shields and none of your hull. Um, most we don't have any energy waste, do we? What will actually? What does that mean? What do you mean by that? Overkill? Oh, interesting. Like, uh, I guess we would know how much energy the target kind has. So energy waste by target kind? That's interesting. That's a neat one too, because it helps you kind of construct your fleet. That's kind of what your fighter ships are for, right? Allow hold to go negative. That could affect how much. Well, allowing hold to go negative. If we did that, that would allow us to also influence how much resources are available. Because if you obliterate it, maybe there's nothing left. Right? It's just vaporized. And we don't have any resources in here either. But in one round, yeah, I'd say a capital ship or well, that deleting's part of the round, yes. But I think that you could very well have um, resource calculations. I think this would be a really neat idea because I think it could also influence people not attacking smaller fleets because it'll just vaporize. They get nothing from it. So unless your goal is to just like obliterate something, you don't send in everything. You'll want to tune it, have it just right, because you want the resources to come back with you. I think that'd be a neat idea. I think that also helps encourage kind of like a more level playing. Yeah, exactly. Yeah, you just obliterated it all. It's you put so much energy into it, you evaporated the steel. You boiled it into space. And I think that'll lead to more interesting battles actually. And I don't know, I like that. Hmm, what do you think? I don't know. 200 to 300% overkill. Like if something only has like 100 hull and you hit it with 300, sure. I think it's definitely worth tuning because that's definitely something that would need to be tuned. But just the idea that if I go in there with everything, I'll come out with nothing. Right? It adds a little bit more strategy to it. And I think when the defender sees that, like something's coming, they might feel like, hey, I have a chance. And not like oh, the game's over. Because you're gonna have to watch your overkill. I think that adds a lot. Probability of vaporizing debris goes up when you have more overkill. Yeah. Oh, keep track of overkill. Hmm. Energy waste, yeah, by target kind. That's what we want there. I think that'd be pretty cool. Okay, let's come back. Let's start to implement this. Round stats. Okay, I'm gonna have to start bubbling this stuff. The target stats first. Overkill has to be averaged across the fleet. Why is that? Use smaller ships? Yeah, yeah, that would definitely overkill it. But I think that's part of the equation, right? Bring in, 10,000 of the kind of fodder, then a couple of the big ones, and the ones that the big ones hit are just gone. I think we could actually do it per ship. That way, if like 10,000 fighters somehow all hit the same thing and completely obliterate it, then it's just that one element getting destroyed, not like all the debris. All right, so for target stats by kind, should probably be a hash map. I think realistically, like the space sim itself, if we can keep it, oh, hmm. I like that. There's like a statistical averaging we could do with this, but we're not, because it leads to some more interesting outcomes. And I think overkill and the obliteration of things should be one of those more interesting outcomes that you didn't get the really good stuff because you brought in the big guns. All right, target stats. Problem with that is it means there is no chance a defender could collect and rebuild, so attacker might do it on purpose. Oh, because the attacker comes in, just obliterates everything and runs without. Because how would they collect stuff? Interesting. So that's interesting in terms of like the defender, but I think it also mitigates the opportunity that somebody would just go around picking off like the new players, right? Because there's no gain for them. Usually you have a class of ship that is slower that collects the debris from the battles, right? Okay. They would get points for killing ships, I see. It's actually gotta get going. Time kind of snuck up on me. Okay, but I think next time we'll probably do a bunch of stats stuff, get that done, and maybe go through some kind of test runs of it. See, yeah, ship kind of the scope. There we go. Cannot find hash map. Let's clean some of this up before we commit it. Standard collections, hash map. Okay. Should be it. We got a bunch of dead code. That's fine. Get cargo. Check that. Good. All right, y'all. Yeah, have a good weekend. I'll probably see you online tomorrow. We're gonna do a raid. Warming up here. Yeah, we're gonna raid Adam again. I have a competition between Adam and Lana. Okay, so next time stats. So we'll be able to do multiple rounds. So then we'll be moving on to the rest of it. It'll be fun. Oh, Adam's doing Godot again today. Oh, that's cool. All right, I gotta go. Until next time. Bye bye.